at the time, a great drive to find stiffer materials for making aeroplanes, bodies stiffer than aluminium. And the strongest materials are always come in the form of fibers. Of course, you can't build an artifact, an engineering artifact, out of a fiber by itself. You'll get a rope or the sort of floppy clothes you're wearing woven. What you have to do is put that fiber with something. Now, my interest in graphite led me to consulting for the Royal Aircraft Establishment. And quite independently of my thoughts, Willie Watt and two other people there thought about making a form of graphite in the form of a fiber, and they chose a textile fiber called polyacrylonitrile, which was essentially a fiber used for making carpets. And they carbonized that fiber and produced carbon fibers. Now, I happened, through my knowledge of what they were doing, and they told me about what they were doing, they then had to make what's called a composite material. I explained that a rope by itself is no good. We need to make a sheet. And so you must have a fiber that is weavable in the same way that it's woven to make your clothes. And of course, a carpet fiber is weavable. So you need to put together the fiber plus something to stick it together, called a matrix. Well, my contribution was essentially to be able to deduce some general rules about how the resulting composite would behave, and principally to explain why it wasn't brittle. You asked what a composite material is. You came to this meeting in a motor car, perhaps, and your motor car had tyres, and tyres are a good example of a composite material. They're a fibre stuck together with rubber. Wood is a composite material, but the high-performance composite materials, fibrous composite materials, are made by impregnating a carbon fiber like that with some sort of resin and making from it a piece like that, or a bigger piece like that, which has fibers running in this direction and in that direction. And we've called it black aluminium because it replaces aluminium, and it's dramatically not brittle. It doesn't break. If I throw a piece of glass on the floor, it breaks, you see. And now you can see the difference. That one didn't, this one did. I'm sure you've all handled the sort of fiberglass mat that you put in your loft to insulate it. Do you know that? Right. Now, if you took something like that and put it in a vessel that was closed and injected a glue, a resin, so it would go in and spread out all among the fibers, and when that resin had cured, in other words, the resin had set, you'd then open the mold, and there would be a solid composite material. So the original thing was a wool-like mass. That's a very cheap form of composite material. If you're going to make a piece that you're then going to use it to make bits of aeroplanes, you want to make sure that you are using the strength of the fibre. So that means it's always going to be stressed along its length. So, this consists of individual fibres. So first of all, consider running something like this through a glue while the glue is fluid. And then while it is still fluid, laying it on a flat sheet and making a thin tape. And this happens to be a tape but with aluminium matrix, so now you've got a thin tape. A very long, thin tape. Now to make this, you're going to have tapes going in this direction and tapes going in that direction of that thickness, and they're going to be woven one above the other, and that will all be done while the resin, the glue, is still sticky. It's called pre-preg, although it is already preg. That's then put in a furnace and the resin cured. And then when you open the furnace, that's what you get out. In the case of steel, and to some extent aluminium, the carbon fibre of the type like this used in an aircraft is corrosion resistant. It doesn't corrode like either aluminium or steel. In the case of steel, of course, it's only between a quarter and a fifth as dense, so it's 5 times lighter, if you like. Over aluminium, because it is lighter and what is called slightly stiffer. Over steel, because it is very, 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 very much lighter, though it is not particularly stiffer. But it's also stronger than aluminium and stronger than steel.